we present intent-driven full-body motion synthesis for human-object interactions. Humans interact with objects in numerous ways. Being able to synthesize these interactions in a virtual 3D environment through textual commands has widespread applications in computer graphics and robotics, movie script visualization, games and animation, to name a few. There are multiple ways to interact with almost any object. For instance, a plausible set of interactions with a cup is to lift it, drink from it, pour from it, or pass it on. Instead of modeling these interactions in 3D manually, an alternative is to learn a motion synthesis framework that accepts an instruction label depicting the object used and the action performed, and that automatically synthesizes a diverse set of desired motions. Existing works on full-body motion synthesis do not consider human-object interactions. They synthesize human motions based on an action label only, whereas existing works on hand-object interaction focus only on synthesizing finger movements for grasping various objects. However, to create plausible motion sequence for a virtual character to interact with an object realistically, modeling hand motion interactions alone is not sufficient. Rather, we believe it's crucial to operate in the space of full-body motion synthesis. While it's possible to map the sparse inputs of hand poses to a full-body pose, it leads to a heavy pipeline in addition to introducing an ill-posed mapping function. Recent works on whole-body grasping like goal estimate full-body motions from a starting T-pose to the moment of grasp using motion in filling, but none of the existing methods addresses how different actions are affected when objects also come into the scene. To address this limitation, we propose the first method to synthesize full-body motion sequences for character-object interactions and optimize for the 60 OF object poses such that grasping constraints are satisfied. We can synthesize generic actions like inspecting, which can be performed with all objects, as well as actions like screwing, which are performed with specific objects like the light bulb. We place special focus on synthesizing interactions involving both the hands. This also includes sequences where the object is exchanged between the hands, a setting that hasn't been addressed before. For instance, we see a sequence where a person exchanges an apple from one hand to another, and another example showing a person holding a camera with both hands for taking pictures. Our motions are conditioned both on the performed action and the used object. Thus, the same action performed with different objects looks different, as we can see in this example. We show drinking actions from a mug as well as a bowl. The bowl is picked up with both hands because of its shape. The differences are learned implicitly by our networks. Also, our synthesized motions show diversity while performing the same task. We show two variations of cooking action with a frying pan, as well as two variations of eating actions with an apple. Note that the person uses one hand as well as both hands for this motion. We accomplish this using our intent-driven full-body motion generator, which is based on a conditional variational autoencoder architecture. It takes in an initial body pose, an object position, and an instruction label specifying the type of object and the action to be performed, and outputs a synthesized sequence of body poses and object positions corresponding to that action. In our generator network, we first encode the instruction labels using our condition encoder. Owing to the varying degree of involvement of the arms and the body joints for object interaction, we designed an arm synthesis module to leverage the intent-based interactions between the objects and the arms and autoregressively synthesize arm movements. We similarly design a body synthesis module that leverages the interactions between the arms and the rest of the body and uses self-attention to autoregressively synthesize movements of the full body. The arm and the body movements are concatenated and passed to our object optimizer module. We designed this module using a surface-to-surface distance metric for each interacting hand-object pair and optimized for the 60 OF parameters of the object such that it plausibly fits within the hands of the synthesized character. We show more qualitative results side by side with the ground truth sequences. Our method shows accurate arm and head movements for motions such as passing the camera. For brushing action using a toothbrush, our method is able to correctly bring the arms toward the mouth and perform the brushing motion. We see another sequence for the off-handing action where the mug is accurately passed from one hand to another. And another example of drinking action with a wine glass where our synthesized motions show accurate head tilt and arm motion. We compare our method with benchmark full-body action synthesis methods. We find that the competing approaches are either inconsistent, output jittery movements, or regress a mean pose. Actor fails to bring the hand all the way to the mouth. When comparing with the benchmarks for both-handed motions, we see our method shows high accuracy in holding an object with both arms. For actor, the arms are angled incorrectly, and for action to motion and TEMOS, we see incorrect poses. We also conducted a user study to evaluate our results against the two state-of-the-art methods. Out of 30 randomly selected samples, the users chose our method in more than 80% of the cases. Here, we compare our method with its ablated versions. We consider 3 ablations, which are discussed in detail in section 4.4 of our paper. We see that our method correctly synthesizes the motion of bringing the glass to the mouth and tilting back the head to drink, whereas the ablations fail to do so. Our method synthesizes the arm positions accurately, which is essential for both-handed motions like browsing the camera. Again, we see that the ablated versions are failing to do so. However, our method has certain failure cases when trying to synthesize motions for some actions it has seen rarely during training, or actions that require high-frequency movements in the wrist and finger joints. In conclusion, we present the first motion synthesis technique to generate full-body motions for character-object interactions conditioned both on the action and the object used. This is the first method to synthesize body poses along with the corresponding 6 DOF object positions during test time. We place special focus on synthesizing interactions involving both the hands. This also includes sequences where the object is passed from one hand to the other, a setting that has not been addressed before. We also account for variability of the synthesized motions. Thank you for your attention.